Okay, so now we're going to be working with the third strategy to solve limits, which is rationalizing. And usually you're using rationalizing when you see a limit like this, where you have a radical in the limit expression, and usually it's a two-term radical. So you may want to review the videos for rationalizing two-term radicals before you watch this one. But what you have to do when you see something like this is just rationalize it, hence the name. So we're going to rationalize the numerator. So we'll multiply this whole expression by the conjugate of the numerator, which is just the same thing except the sign in the middle is changed. So we'll have 3 plus root 9 plus x. So this is like essentially multiplying the expression by 1, which will keep it the same, but it will change its format. Remember, our goal is to get rid of this x in the denominator, and we can't directly substitute right at the beginning, because if we plug in 0 for x, we'll have a 0 in the denominator, and that'll make it undefined. So we need to algebraically manipulate it a bit to get rid of this x. So when we multiply it by its conjugate, the numerator by its conjugate, it'll be a difference of squares. So the two middle terms containing the rationals will cancel out, so we can just multiply the n pieces. So 3 times 3 is 9. Sorry, let's write out this limit here. So limit as x goes to 0. 3 times 3 is 9. Minus root 9 plus x times root 9 plus x is just 9 plus x. All over. Let's keep these separately. So when I see a lot of times when students are multiplying these two expressions, this x and this 3 plus root 9 plus x, sometimes they like to distribute the x inside. But I suggest to keep these separately, because remember, we want to get rid of this x. We're going to cross it out eventually. So in the denominator, keep these separately and don't distribute the x inside. And then what happens is we'll distribute the negative inside the numerator. So we'll have the limit as x goes to 0 of 9 minus 9 minus x all over x bracket 3 plus root 9 plus x. So we're keeping the denominator separate. I'm going to continue this this question here. So the limit as x goes to 0, and then notice how in the denominator the 9's will cancel out. They'll net out to 0, and we'll just be left with a negative x in the numerator. And then in the denominator, we'll keep it the same. We'll have x, and then 3 plus root 9 plus x. And then the x's cancel out, which is what we want. So we'll have the limit as x goes to 0 of negative 1 over 3 plus root 9 plus x. And now we can plug in a value for x in the denominator, and it won't equal 0, so we'll have negative 1 over 3 plus root 9 plus 0 is just 9. The root of 9 is 3, so the answer will end up being negative 1 over 6.